percentage of modulation it is. Okay, so I'll just get my calculator real quick. You can see if I grab this, it's 5 divided by 15, right? We're talking about 33, right? So this guy just so happens to be 33.3, we'll just say 33% modulation. Okay, so that's how we decide or we calculate the modulation. Now, it's important to note that for receivers, we try to get close to 100 as possible. And for that reason, it's so that we can extract the most accurate intelligence possible. Okay, so the more we got an amplitude here, the better our intelligence or the quality of our intelligence is, so we can extract it. Okay, so now the first step we're going to go through is I'm going to go through each one here as far as how it's done. We got... Oops. Okay. So one thing I wanted to point out at this point is we have different types of modulation. So I went through one example of how we modulate, but we also modulate at different times, okay, or at different points. There's some advantages to this, mostly in power and some other reasons for this, right? So we have two types. We have high level and low level, right? Low level modulation, right? So there's some conditions where you might want high. There's some conditions when you might want low modulation. Okay, so the difference between high and low modulation is strictly at what point do you introduce the two signals together. Okay, so what we have here is the block diagram of the collector modulator. Now I go into the slide on how the collector modulator works. Essentially, it's a Class C amplifier. Okay, so the carrier is we adjust the carrier signal to the base of a transistor, and we set a negative potential there so that we bias that transistor only on the peaks of the carrier wave. That way there, the output goes into a tank circuit, and then we're left with just spiking that tank circuit to create that same the same thing we saw here, right? Through the diode, we only do the positive peaks and we spike the tank circuit just to create its flywheel effect, okay? Which produces this oscillation that we see here. So what we have here is the complete thing. You can see that the first thing that happens is the microphone. Now, it's worth noting that any kind of device like this, when we have, you need some sort of power here to create this kind of audio, your spoken voice through a transducer like the microphone. So the first thing we're going to do is we're going to amplify. We're going to amplify the signal. So if this was your signal coming through, we're going to get a bigger signal. We're going to amplify it. We're going to do some filtering. We're going to kind of try to clean it up, right? And then we're going to go into a push-pull type modulator in order to basically boost, get the signal ready, okay, to going through a coupling transformer. Okay, we're going to go through like type of a push-pull type amp. Again, we're going to do some impedance matching here for efficiency, right? So we don't lose any of our signal. Our power, because we're going to see that at this point here, power is crucial. Okay, so we want max power at this point. So when the signal comes through here, now we have our intelligence, right, sitting here, and then we have an oscillator. So remember all those in the lesson, we go through a little bit of review between the Colpitts, the Hartley, all these types of different oscillator, the clap oscillator. This one's a crystal controlled one because there's the crystal, right? It's at 27 megahertz. So that tells you right away the carrier frequency is going to be 27 megahertz. Okay, so we're mixing 27 megahertz with whatever that is as far as when I speak. So if I'm speaking now, I'm speaking at a certain tone and a certain pitch and at a certain level. The how loud I am would dictate how the size of this amplitude, and then the tone of my voice would be the frequency. Okay, so say for just argument's sake, it's I don't know, let's just say it's like 500 hertz. I don't know. We'll just say that 500 hertz coming in here. So we'll say just as 500 hertz. Okay. So when I mix this, so now notice this is a carrier oscillator, so it's just an oscillator circuit, and it's always producing this. The carrier signal is always going to be 27 megahertz. So we have very low power out the oscillator. The first thing we're going to do is, again, just like we did here through driver, we're gonna boost the signal. We go up to 350, so a bigger size power. Now this guy here, he's got a decent amount of potential, and he's got a decent amount of power. He's 2.5 watts. We need to get him at a certain level. So this guy's coming in at 350 milliwatts. We're going to combine them. We're going to go through a transistor class C type amplifier, right? And then we're going to get our amplitude modulated signal. With that, we're going to have, what we're going to have is something that's going to be, I'll do my best here, all right?